Hi, I'm Kirby Jason R. Bautista. I'm from BSEE 2C and my instructor is Engineer Ellen Jane Goldblum. So I'm gonna discuss about Chapter 6, Capacitor and Inductor. So capacitors, it consists of two conducting plates separated by an insulator. It is a passive element designed to store energy in its electric field. So, capacitor is a one kind of passive element like resistor, inductor, and many others, which is dagan siyang magamit sa electronics. So basically, ang construction sa capacitor na ay duha ka metal plate, which is this one, in parallel and dielectric with permittivity, which is siya ang define nga unsa nga type ng material ang ginagamit as insulator dato sa capacitor, which is could be air, ceramic, paper, and mica. Okay, so today, when a voltage source is connected to a capacitor, the source deposits a positive charge on one plate and other negative charge in the other. So, dire, if kaning voltage source nag-supply siya positive dire sa pa-left and negative dire sa pa-right. Okay. The capacitor is said to store the electric charge. The amount of charge stored represented by Q is directly proportional to the applied voltage V, so that Q is equal to CV, where C, the constant proportionality, is known as capacitance of the capacitor, and the unit of the capacitance is the farad, or contributed by Michael Faraday. Michael Faraday was an English scientist who contributed to the study of electromagnetism and electrochemistry. So the ratio of charge on plate of capacitor to the voltage difference between the two plates is measured in farads, where 1 farad is equal to 1 farad is equal to 1 coulomb per volt. We're using this formula, Q is equal to CV, we can solve for capacitance, which is capacitance is equal to Q over V. Therefore, using this formula, the higher the charge, the higher the voltage, but lower the capacitance. Okay. Although, natay formula nga capacitance nga dili siya ginapindi, which is this one, kani nga formula, dili niya dipindi dire sa charge and voltage ang iyang value sa capacitance, but instead sa construction niya. Okay. Sorry. Okay. So kaning formula, so this is the formula that we're gonna use to find capacitance based on parameter in the instruction, which is capacitance in measured in farad, and epsilon is permittivity of dielectric material, and A is for the area, and D is for the distance. So, kung i-analyze nato ang formula, we can get the relation between the capacitance as well as dimension of the parameter. So, the higher the area, the higher the capacitance. And if ang distance niya is low, and also yung capacitance. Okay. If iyang permittivity or epsilon is high, and also the capacitance. Okay. Symbol of capacitor. Non-polarized capacitor, hindi siya, is just a parallel line duha ka metal plate. And next is polarized capacitor, which is na siya curved line. Curved line and straight line. So, sa variable capacitor, same lang siya sa non-polarized capacitor nga nalang siya mag incline nga arrow, incline nga line. Okay, next will be passive sign convention. Okay, if current enters the positive voltage polarity, which is diri maagi ang current, the voltage is positive and the capacitor is charging. So, ga-charge siya kay naagi man siya sa positive diri So, if the current enters the negative voltage polarity, V is negative and the capacitor is discharging. So, since diri man naagi ang current, iyang capacitor will be discharging. Okay, yung agi mo siya sa negative. Okay. So, current voltage relationship. Since, like I said earlier, capacitor is said to be store energy. So, sa resistor, atong ginagamit nato ang formula kay Ohm's law aron ma-determine ang voltage and current relationship sa resistor. Kung sa capacitor pod, medyo siya complicated kay magamit tag DE or differential equation. So, where current of capacitor is equal to capacitance derived by voltage respect to time. Okay, where I is equal to current through capacitor is measured in farad, and V is equal to voltage across the capacitor measured in volts, and C is equals to capacitance measured in farad, and V over dt is equal to change of rate of voltage. So, ito. Diri na gasunod tong change of rate of voltage sa capacitor, because we will know that capacitor are resisting the charge of voltage which is depend on capacitance. So, using this formula, we can solve for the voltage. This one. We can integrate both side, and we can get this. V is equal to 1 over C integral of I dt from t to 0 to t plus V of t tau, or t naught on t naught. So, let's assume this t naught is initial charge of the capacitor. Kung tag initial charge mo good sa capacitor, automatically 0 na siya, no? Equals to 0 na siya. Equals to 0. Okay. Current voltage relationship. So, yung graph niya to. So, let's say nga, yung y-axis is I, current, and x niya ay change of rate, or dV over dt, or the voltage of the capacitor. So, this is the slope C. This is the one that determine the resistivity of the capacitor in change of rate of change of the voltage across it. Okay. energy stored in power in capacitor. Just like the resistor that dissipate energy in power, we have also for capacitor, which is siya. So 1/2 CB squared, or E is equal to Q squared over 2C, where E is equal to energy measured in joules, and Q equals to charge measured in charge, and C is equal to capacitance measured in farad, and V is equal to voltage measured in V. Characteristics of capacitors. A capacitor is an open circuit to DC, where I is equal to 0. However, if a battery or DC voltage is connected across the capacitor charges. So, in the sample na tayo voltage, battery voltage, switch, and capacitor. So, let's say at long period of time, open pa ang circuit, and close din nato. Pag close nato, let's say na ay voltage diri sa battery, nanay voltage diri, kaya naka-close na, kasi nga close na ni, and ikan sa voltage nga battery mo charge ang capacitor, at certain time constant ikan sa battery, and di siya mo charge nga ditso. Let's say nato graph 3, di siya mo charge diretso na may battery, di siya mo charge ditso na, kundi it will take time muna pag bigani pa, will take time. Dili siya dito nga straight pataas, kundi incline na siya, incline nga sundan, mapabukid siya. Okay? Kaya voltage kanan change instantaneously. Okay. So number 2, the voltage on the capacitor must be continuous or cannot change abruptly, but the current through capacitor can change instantaneously. So said to be continuous. So let's say diri wala man siya nag instantaneously taas, wala siya nigani, hindi niagi pa siya diri nigani pa-incline, and incline siya or pabukid ayon yung forma, possible ni siya kay wala man siya dito ni instantaneously, wala ni siya ni yung voltage wala siya ni taas dire, kundi niagi pa siya dire niya incline, and wala pa siya nag change abruptly. Okay, paubos din siya, and continuous din siya, which is possible din siya nga graph, unless diri sa pikas nga iyang voltage ikan diri ipataas dito abruptly, instant siya itaas, which is possible. So this kaniyang voltage dili pwede, kailangan na siya specific nga time para maka-achieve iyang final voltage nga gina-supply sa iya. So this is not impossible. So ideal capacitor. The ideal capacitor does not dissipate energy. It takes power from the circuit when storing in its field and return previously stored energy when delivering the power to the circuit. So take a note word ideal. So dili dayon ga dissipate og energy ang capacitor, but instead kwaon ra niya ang energy for a period of time and then transfer another component within the circuit after some time. For the ideal capacitor, the power is 0. So, sa non-ideal capacitor, a real non-ideal capacitor has a parallel model leakage resistor, can be high as 100 milliohms, and can neglected for the most practical appliances. So, diri not leakage yang resistor. So, there's no such thing as capacitor. In this sample natay, na-connect nga leakage, which is this one, leakage in parallel. So, this is one that dissipate in capacitor. Although we have a leakage resistance and measured dasa sa 100 milliohms, in which is pwede din siya ma-neglect. So, parallel and series in capacitor. Capacitor, parallel. So if natay parallel capacitor, let's say, during a picture, natin tayo current source, and then, so, same nagyapon, ang ma-apply nga formula, basta mag-consider tag parallel combination of resistor. So, for the current, i-add lang ning mga individuals. Ano sila? I1, I2, I3, till IN. So, I is equal to I sub 1 plus I sub 2 plus I sub 3 until I sub N. And para sa CX, which is connected in parallel, represent nato as a equivalent capacitor. Sa parallel capacitor sa circuit, and then igani yang gawas. So C is equal to C sub 1, C sub 2 plus C sub 3 plus C sub N until C sub N. I-add na silang tanan. The equivalent capacitance of n parallel connected to capacitors is the sum of the individual capacitance. And sa series capacitor, we have capacitor connected in series C1, C2, C3 plus until C sub N. Same nagyapan yung series resistor na formula itong total voltage. So, V sub 1 V is equal to V sub 1 plus V sub 2 plus V sub 3 until V sub N. And iyang equivalent capacitance will be 1 over C or C equivalent. So, 1 over C sub 1 plus 1 over C sub 2 plus 1 over C sub 3 until 1 over C sub N. The equivalent of capacitance of N series connected to capacitor is the reciprocal of the sum of the reciprocal of the individual capacitances. Okay, it is a sample problem. It solves a sample problem. So, what is the charge of store on 3 picofarad capacitor with 20 volt across it? How much energy is stored? So, ang una na itong button na ni is, what is the charge? So, ang charge, yung formula niya is charge kay Q is equal to CV, which is, ang capacitance na ito nga 3 picofarad, which is 3 times 10 to the power of 9 times 20 volts, which is, kung i-multiply ni mo ni tanan, which is 60 times 10 to negative 9 farad. and energy store energy, which is kanina yung formula. So 1 half CB squared, because so 1 half CB squared plus 3 times yung capacitance nga 3 picofarad, so 3 times 10 to the power of 9 times 20 squared. So yung mo nang i-calculate, you can get 600 times 10 to the power of 9 joules. So kanina sum ito, obtained energy stored in each capacitor under DC condition. So dito sa circuit natin 6 milliohms, 3 kilo 6 milliamps, 3 kilo ohms, 5 kilo ohms, 4 microfarad, 4 kilo ohms, 2 kilo ohms, and 2 microfarad. Kung ato nang i-analyze, ang circuit is under the DC condition, which is kung atong i-rewrite redo ang circuit kay ang capacitor is said to be an open circuit sa DC. Okay, i-redo na to. Gani na. So na ay may volts nga sa V1 o V2. And since obtain man daw ang energy, so magamit ta ani nga formula. Since tay capacitor C1 siya, C1 C2. Okay, and since na naman tay capacitor, ang kulang lang is voltage. Let's find voltage. Okay, so basta itong gamitan ani pag solve. You can say that pwede tayo magamit og current division. So I equals to 3 kilo ohms plus 3 kilo ohms plus 6 kilo ohms. So okay, so diri nga kani nga ohms ay kilo ohms, wala na ni siya. Okay, similar na siya node diri og node diri, wala na ni siya dai. And kaning 2 kilo ohms og 4 kilo ohms series man sila, pwede na sila i-plus. Okay, so 3 over 3 plus 6 times 6 nga milliamps, okay, is equals to ang I na to is equal to 2 milliamps. Okay, since nanatay I using Ohm's law, V is equal to IR, makuha na to ang volts in each capacitor. Dire V1, kasi nga V1 dire ano na C1 C2. Okay, paano na to ay lang each voltage. Okay, which is V1 is 2 milliamps nga nakuha na to ganina ang I, and 2 kilo ohms nga dire yang parallel across, and we can get 4 volts. Okay, dire po sa because V2 is 2 milliamps times 4 kilo ohms is equal to 8 volts. Since na naman tayo volts in each capacitor, you can now use this formula. Yan na naman tayo capacitance and na tayo volts. But in this formula, we can get 1/2 of 2 times 10 raised to negative 3 farads times 4 squared, and kung i-calculate na to, we can get 16 times 10 raised to negative 3 joules or 16 microfarad. Dito sa C1 or capacitor 1. And sa capacitor 2, you can get 1/2 of 2 times 10 raised to negative 3 farads times 8 squared is equals to 128 times 10 raised to negative 3 joules or 128 microfarad. So our next topic will be inductor. So ang inductor, just like resistor and capacitor, ang inductor is also a passive element. So basically, ang inductor makonsider nato na counterpart sa capacitor. Where inductor have many application in electronics also. Okay, let's define what is inductor. A passive element used to store energy using in its magnetic field consists of a coil of conducting wire. So, ang inductor mag-store siya energy using magnetic field in the form of current. After some time, i-release niya to para magamit sa ubang element sa circuits. Let's say for example sa tiling nga picture. So if we consider the instruction of a inductor, isa siya nga wire nga gi-wind sa coil. So this is the core. This is the core, which is could be different type of material. Could be iron, steel, plastic, and air. And this is the number of turn. And yung area, cross-sectional area. And also yung length. Okay. Symbol of inductor. So first is air core inductor, which is fixed. Okay, there's no specific core. No? Air naman siya, wala siya metal or mga material. And we have iron core, which is still the same in the air core symbol, but it has a parallel line nga ga-denote nga naa siya core. Ano naman siya kana parallel nga murag plate or core niya. And then we have a variable core, which is same gyapon sa air core pero nalan siya slot line. Slot line. Okay. So in this picture we have the different type of inductor, which is makita nato sa electronics. As A is solenoidal, this one, and B is toroidal inductor, and C is chip inductor, which is the term coil and choke are also used for inductors. So matawag na to siya coil or choke for inductor. So let's go to this formula for inductance. Na formula in terms of parameter that we consider the inductance, which is L is equals to N squared nu times A over L, where L is inductance measured in Henry, and N is number of turn, and nu is permeability of the core, and A is cross-sectional area, and the length is L is the length. Okay. Current voltage current relationship for an inductor. If current is allowed to pass through an inductor, it is found that the voltage across the inductor is directly proportional to the time rate of change of the current. Okay. In this sample, we have current passed through the inductor, and then IL, and then there will be induced voltage such that it is directly proportional to rate of change of current with respect to time, and then the constant proportionality will be inductance or kaning L. Okay. Inductance is the property whereby the inductance opposite the change of the current flowing through it, which is measured in henries. So 1 Henry is equal to 1 volt per second over ampere. So therefore we can define the inductance as the property of inductor that opposes the change in current. So kung sa capacitor, it is opposes the change in voltage, o sa capacitor po ay sa inductor, it is opposes the change in current, which is sa kanina graph sa atong y-axis is voltage VL, and our x-axis will be di over dt or rate change of current, and this is our slope L. Okay. Now other formula na pwede nato gamiton for inductor. In these formulas, for the IL, base diri sa kaning nga formula, we can get, pwede nato ma-derive ni ang V is equal to L di over dt, o ato nang manipulate, makuha ni nato ni nga formula, this one, which is 1 over L integral of Vt dt from t0 to t plus it naught, which is ang it naught or kaning t naught is ang initial value sa inductor is equals to 0, and the power, which is measured in watts, is just equals to Vi or V times I, where V is equal to this one, L di over dt times I na dayon. So for the energy, which is measured in joules, could be 1 half over Li squared. This one. Okay. So characteristic of inductor. An inductor act like an short circuit to DC. The voltage across an inductor is 0 when the current is constant. So kung sa capacitor, ang equivalent nato sa capacitor in DC is an open circuit. Og sa inductor naman, it is an short circuit sa DC. So for example, natay supply current and inductor, which is natay supply nga current og inductor, which is kung nasupplyan daw nato ning kuan inductor at a certain period of time, ang may tabuan ni nga kuan element will be short circuit. So kung atong i-redraw, ang circuit na mabuo is like this, short na, and the voltage will be equal to 0. So, the current through an inductor cannot change instantaneously. However, the voltage across the inductor can change abruptly. So, since ang characteristic sa inductor kay ga-resist sa sudden change in current, therefore, kailangan naay waveform nga continuous for the current. So, in this waveform, wala niya gi-violate ang characteristic. So, let's say at this region, diri ang initial value sa current, and then at this portion, let's say T1 na siya, T1, and T0, wala niya na-reach dito diri nga point, wala niya dito na-reach diri nga point instantaneously or kalit lang, but naay delta t na naay value diri na diri dapita nga dili equal to 0 kay niagi po man siya diri nga point taas ay siya naka-reach diri which is unlike diri sa Picas waveform nga posible kay nag-start siya sa 0 and ang current sa inductor, and then instantaneous na current siya diri, which is duration sa delta t is 0. Therefore, it will have a infinite spike or high voltage spike sa diri nga portion, which is possible. Like the ideal capacitor, the ideal inductor does not dissipate energy. The energy stored in it can be retrieved at a later time. The inductor takes power from the circuit when storing energy and delivers the power to the circuit when returning the previously stored energy. So, pareha sa ideal capacitor, nag-store of energy through voltage. Sa inductor, then ga-store gyapon this time through current and does not dissipate power unless it's not ideal, because naay mga parasitic resistance and capacitance. So like capacitor, i-store niya una sa inductor ang energy through current, and then later time i-pass through lang niya sa component within a circuit. So murag na wala kay ma-dissipate na energy or power sa iya. A practical non-ideal inductor has a significant resistive component called winding resistance or RW and winding capacitance CW through the capacitance coupling between the conducting coils. Okay. So there no such thing as ideal inductor. So per me na ay non-ideal inductor because dili pwede mawala ang mga parasitic. For example, diri sa inductor na ay winding resistance. So, ano siya? Winding resistance. So, siya ang gakos sa inductor para na ay loss. Okay? Ang wire na to kay na ay resistance. Maskin gagmay. And since ang inductor na to is made up of wire na gi-wind, therefore, there's a resistance. Same as on na ay ma-create or ma-develop nga winding capacitance. Just this one. And so this is non-ideal form na pwede nato ma-form basta i-consider nato practical nga inductor. Okay. Find the current through a 5 Henry inductor of the voltage across it, which is V of t is equal to 30 t squared if t is greater than 0, and 0 if t is less than 0. So also find the energy stored at time equal to 5 seconds. Assume that I of v is greater than 0. So using the current formula for inductance, you can use this one, which is 1 over L integral v of t dt from t to 0 to t plus I of t naught, which is atong ibutang to ilang value, which is 1 over 5 nga Henry integral of 30 t squared, which is from time is greater than 0 and from t0 to t plus 0. Kaya atong initial value sa t naught is 0. And if atong ining and 30 t squared atong i-derive, can get 1 over 5 times 30 t cube over 3 is equal to 2t cube from 0 to t. Okay, is equal to 2t cube minus 2 of 0 cube, or simply just 2t cube amps. So you have now a current. Okay, next will be find the energy stored at t equals to 5 seconds. Okay. Ang formula sa energy is this one, 1/2 Li squared, which is ato itong i-compute ganina katong nakuha na to, which is 1/2 5 nga Henry, o katong ganina nga result is 2t cube and times lang siya 2. So you can get, if ato nang distribute and 1/2 5 times 2 times 2 is 4, which is, and 2 times 3 is 6, or t to the power of 6. And if we simplify this, you can get t 10 t to the power of 6. And if at time, and then we have a condition that at t is 5 seconds. So 10 times 5 to the power of 6 can get 156.25 kilojoules. This one.